Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is Cambridge O Levels Physics 5054. Today we have set our hearts to solve a theory paper. We call it paper 2. And for this purpose, we have selected October-November 2022 2-1 paper. This paper 2 belongs from the zone 1 or the variant 1. In this video, we are going to attempt the section B of this paper. The section A of this paper I have already solved, and I made a video and uploaded in my YouTube channel. You can find that video in the playlist by the name of paper 2 zone 1 section A. I will also paste the link of that video into the end cards of this video. Okay, so let's start. In this video, we are going to attempt the section B of this paper. So we will be starting from the section B. So here we go. This is October-November 2022 2-1 paper. It's section B, which is starting from the question number 7. He says figure 7.1 shows a child sitting on a sledge on a snow-covered hill of constant slope. So this is the sledge, this is the child sitting on, these are the brakes, this is the snow-covered hill, and here we have a wall. So their question is, at time t equals to 0, the child and the sledge begin to move down the hill in a straight line. When the child sees a wall ahead, he applies the brakes. The child and sledge continues to travel in a straight line until they come to a stop before hitting the wall. So remember this story. He applied the brakes. He did not hit the wall. He stops before hitting the wall. Okay. So their question is, here we go. He says figure 7.2 is the speed time graph for the journey. So here we have the speed. Here we have the time 0, 4, 8, 12, 16, 20, 24, 28, 32 seconds. So at the time t0, here we have the speed 4, 8, 12, 16. At time 0, the speed is 0. Then the speed increased. And if you look at this diagram, it is represented with a curved line. Its gradient is gradually decreasing, which means that the acceleration of the body is gradually decreasing. And at time t equals to 22, the acceleration becomes 0, the velocity becomes constant. At 26, it starts decelerating, and at 20, I think this is 30, it comes to a stop. Okay, so the maximum speed here is, I think, it is 15.2 meter per second, I think. Okay. The brake is applied at t equals to 26 seconds. So at t equals to 26 seconds, the brakes are applied. A part is figure 7.2 shows how the speed of the child and sledge varies over the whole of the journey. Explain why between t equals 0 and t equals 26 seconds, the speed varies in the way shown in the figure. So here, basically, the speed is increasing up till t equals to 26, and then it becomes constant. Why this happens? Because you see at the start, because the sledge is coming downward, so one component of the weight is responsible for moving it down the slope. And as it gains speed, the air resistance which is acting on that child and the sledge, that increases. So as the child and sledge, they get speed, and the air resistance they are experiencing also increases. At some point, what happens? The air resistance becomes equals to the component of the weight which is producing the motion, and then the resultant force becomes 0, and the acceleration becomes 0. The body moves with a constant speed. So during this, you see, as the air resistance is increasing, the resultant force will be decreasing. So the acceleration value will be gradually decreasing. So this is the motion. This is my description. It's a 3 marks question. And let me show you my answer. So we have question number 7A part. I have written quite a large answer, so let me increase the size, decrease the size. Okay. So here we go. The child and sledge are accelerating from t0 to t22. Velocity of child is increasing, but value of acceleration is gradually decreasing. After 22 to 26 seconds, after 22 to 26 seconds, acceleration becomes zero and velocity becomes constant. As the speed increases, the air resistance acting against the motion increases. At t equals 22, the air resistance becomes equal to the component of the weight which is causing the motion. Resultant force becomes zero at that point when the forces are balanced. The resultant force becomes zero, velocity becomes constant. This is called the terminal velocity. This is my answer. So let's have a look at the marking scheme. The marking scheme says acceleration increases in speed and gravity weight mentioned. Air resistance friction increases with the speed, and the terminal and the constant velocity read or air resistance becomes equal to the accelerating force. So I hope this answer is right. You can write a better answer, I hope. Question number 7, it's B part. At t equals to 26 seconds, the front of the sledge is 35 meters from the wall. Determine the distance between the front of the sledge and the wall when the sledge stops. Okay. Now, this is the, so I will, okay, so this is 26 seconds. So I will draw a line here. Oh my God, my line is little. Okay, so this shape is basically a triangle. So I can find the area under the speed time graph is equal to the distance traveled. So I will find out the area of this triangle, and that will tell me how much the sledge has moved after 26 seconds. And then the sledge was 35 meters from the wall when the brakes were applied. So I will find out how much distance the sledge has covered during these brakes and the braking distance. And then from 35 meter, I will subtract that. So in front of you, the solution is showing up, and here we go. The distance moved by the sledge when the after applying the brake, that will be 1 by 2 into 4 into 15.2, and that will be 30.4 meter. And because when they applied the brakes and they were 35 meter from the wall, and during the brakes they have the braking distance is 30.4 meter. So how much is the distance between the wall and the sledge when they have come to rest? That will be 35 minus 30.4, and that will be 4.6 meter. Let's check. 4.6 meter is the right answer, sir. And I hope you have understood this idea. And let's move to the next part. So question number 7, C part. At t, the question is, okay, C part. At t equals to 26 seconds, the child and sledge begin to decelerate. Determine the size of the deceleration. Okay, so you know the gradient of here, they want me to find out the gradient of this line, that is equal to the deceleration. So the deceleration here, I will take this point, which is 26, 15.2, and I will take this point, which is 30, 0, and I will apply the formula of the gradient, which is y2 minus y1 divided by x2 minus x1. The gradient of this speed time graph here will be equal to the deceleration. So the a value will be, I have taken these 2 points, and y2 minus y1, 0 minus 15.2 divided by x2 minus x1, that will be 30 minus 26, so it will be minus 15.2 divided by 4, and that will be 3.8 meter per second square, and it will be negative. When I will give my final answer, the word is deceleration. For deceleration, because the word is deceleration, that's why I will not put the negative sign with it. So the final answer is deceleration value is 3.8 meter per second square. 3.8 meter per second square is the right answer, sir. Okay, so then the question is, the mass of the child is 46 kg and the mass of the sledge is 9 kg. Calculate the resultant force on the child and sledge as they decelerate. So I know the force of acceleration. I know the deceleration, the total mass of the child and the sledge, that will be 46 plus 9, that will be 55 kg. According to Newton's second law of motion, F is equals to ma. F is the resultant force. Mass is 55 kg. Acceleration, the deceleration actually, is 3.8 meter per second square. Just multiply them, you get 209, which is approximately 210 in two significant figures. So 210 Newton will be the resultant force. 210 Newton is the resultant force. So I hope you see this is the solution. I hope you understand. Then the question is, he says, state the energy transfer that is taking place as the child and the sledge decelerate. So you see, here they have applied the brakes. So the potential energy and the kinetic energy, they are converting into the thermal energy. So my answer is kinetic energy and the gravitational potential energy of child and sledge is converting into the thermal energy. From kinetic energy and from gravitational potential energy to thermal energy and no intermediate energy. Okay, so our answers are right. This is my answer. Okay. Then the D part, question number 7, D part, at t equals to 26 seconds, when the brake is first applied, the child jerks forward on the sledge. Explain why. You see, when the brakes are applied, because there is some issue with the internet. Due to the some internet issue, the video recording was stopped and now it's again. Okay, so at t equals 26 seconds, when the brake is first applied, the child jerks forward on the sledge. Explain why. You see, the child has mass and it has inertia. And inertia is the characteristics by which the body will resist any change in its motion. So due to that inertia, the body of the boy wish to continue that state of motion, but because the sledges, the brakes have been applied, so the body wants to continue the motion. So that's why the child experience a jerk in the forward direction. Okay. So due to the inertia of child, his body resists any change in its state of motion. That's why he experienced a jerk in the forward direction. Okay. Due to his mass or mass mentioned, his mass resists a change to its state of motion. That's the answer. Question number 8 coming up on your screen. He says, a parallel beam of light traveling in air is incident on a glass lens. The beam is perpendicular to the lens as shown in the figure 8.1. The dashed line P indicates the position of the lens. The center of the lens is dot C. Okay. So he says the lens is a diverging lens on the figure 8.1. Indicate the shape of the lens by drawing the outline of the lens and around the dashed line P. It's a 1-mark question. Draw the path taken by each ray of light after it passes through the lens. Okay. So let me show you. So this is the shape which you have to draw. This is a diverging lens, or we also called it concave lens. And about these rays, suppose this is the focal point of that lens. So this ray, which is coming parallel to the principal axis after passing through the lens, from here, I will join this point with this. I will make a dotted line, and along this line, I will draw this line. So this ray will be diverged. So this ray, which will passes through the optical center, it do not deviate, it goes undeviated. This ray, which is parallel to the principal axis, when it comes here, and I will join this with the F, and along this line, I will make these dotted lines. I will draw this line. It will be diverged. So this is how the parallel beam of rays, after passing through a diverging lens, they diverge. I hope you understand. So this is the solution, the answer of the A first part and the A second part. Okay. Now we are going to the next B part, question number 8, B part. He says, diverging lenses are used to correct short sight. Figure 8.2 is a simplified diagram of a short-sighted eye. Light from a distant object strikes the eye lens and enters the eye. On the figure 8.2, continue the three rays in the eye until they reach the back of the eye, which normally we call it retina. So back of eye, so short-sighted eye. This is a short-sighted eye. So in short-sighted eye, the actual the defect is that this lens, its focal length becomes smaller than the normal focal length of the eye lens. So what happens? The light rays, instead of focusing on the retina, they focus before the retina. So they will not focus here, they will focus here. Let me show you. You see, the focal length of this lens of the eye has become shorter. So the light rays which are parallel to each other, one passing through this eye lens, which is a convex lens, and they focus before the retina, not on. They are supposed to focus on the retina. They focus before the retina. So this is the diagram which you have to draw. So he says continuous of the three rays meet at a point, and on continuation of the middle ray, meeting point within the eye and rays strike back of eye at different places. Okay, so our diagram is right. Okay, then they say, state how the image of a distant object detected by a normal eye differs from the image detected by the short-sighted eye. In the normal eye, you see the light rays in a normal eye. The light rays, let me show you from here. In the normal eye, these light rays, they will cross each other like this. The point of intersection will be here. So the image perceived by that person will be clear, sharp. But in the short-sighted eye, they are focused here, not on the retina. So the image seen by the short-sighted person of a distant object will be blurred. Okay. So let me show you my answer. In normal eye, image is formed on retina. In short-sighted, image is formed before retina. So the image perceived by the short-sighted person of distant object will be blur. Okay. So the image is sharp, focused, not blur. So the normal person will see the sharp image, a focused image, but the short-sighted person will see a blurred image. This is my answer. You can write a better answer, obviously. Explain how a diverging lens corrects the sight of a short-sighted eye viewing a distant object. You see, you put a diverging lens before the eye to correction of the short-sightedness. And what that diverging lens do, it diverge the light rays before they enter into eye. So before they enter into the eye, the light rays are little diverged. So when the lens of the eye focus them, it will focus them on the eye retina at the back of the eye. So you will be able to see the sharp image. So diverging lens diverge light rays before they enter into eye. This helps to focus light ray on retina, or you can say back of the eye. He says the light diverges before entering eye or meeting the point now on the back of the eye, or we can say retina. Okay, so question number 8, C part, he says the focal length of the diverging lens is 4 centimeter. The object of the height, which is 3.5 centimeter, is placed and 6 centimeter from the center of the lens. Figure 8.3 is a full-scale diagram drawn on a grid on which the dashed line L represents the lens and the arrow O, the object. So this is your object, okay? So by drawing on the figure 8.3, let me reduce the size so you can see the whole thing. By drawing on figure 8.3, find the position of the image I of the object O. Draw image I and label it I. It's a 4 marks question. So very simple. Let me show you first of all what you will do. First of all, I will point out what is the F. It's 4 centimeters, 1, 2, 3, and 4. So put a dot here. So this is the principal focus. From the top of the object, start a line which goes from the optical center of the lens, and this line will go undeviated. Okay. Then start a line from the head of the object, which is parallel to the principal axis. And after passing through the lens, join this point and the F, and it will be diverged along this line. Okay. So where this dotted line and this line intersect each other, here will be the head of the image. So from here, measure this height, that will be the height of the image. Measure this height, that's the height of the object. Then their question is, explain whether the image produced is real or virtual. You see, this image is formed by this light ray, and this is not the real. This dotted ray does not mean it's a real ray. Real ray is here. So this image will be a virtual image. This image will be a virtual image. It is a virtual, it's a virtual image as rays do not pass through image C. All the rays, this ray is imaginary. This is not the real ray. So this image is virtual because you can only see when you see from the other side through the lens. Okay, this is only visible when you look through the lens. Okay, so you can write this in your answer. It says on the figure, on the grid in the figure 8.3, write an IE in a position which an eye can see the image. You can see this image if your observer is here and you look through the lens. You have to look through the lens to see this image. Okay. Then the question is determine the linear magnification produced. Okay. So the formula for the linear magnification, there are two formulae for the linear magnification. The one is the height of the image divided by the height of the object. The other formula for the linear magnification is the distance of the image from the optical center of the lens divided by the distance of the object from the optical center of the lens. So I am going to use the height of the image height of the image divided by the height of the object. You can measure them because this is on the grid. You can easily count the scales, the squares also. So the magnification is equal to the height of the image divided by the height of the object. And that will be 1.5 divided by 3.5, and that will be 0.428. So the linear magnification is 0.428. And that is within this range. So our answers are right. Okay, so we are on the question number 9. He says the power supply in an electric circuit is a battery of electromotive force, EMF, of 12 volt. Question number 9A part is state two ways in which the EMF of a battery differs from that of an alternating current power supply. Okay, so the EMF of a battery, the battery gives us the DC supply, and you see in the DC, its direction of the EMF do not change. In the alternating current, the direction of the EMF is periodically changing. Another very important thing is the magnitude of the DC EMF remains constant. The alternating EMF, its magnitude periodically changes. So these are the two main differences. Let me show you my answer. Direction of the DC do not change and magnitude of the DC remains constant. Here, the magnitude of the DC remains constant. Direction of the DC do not change, but the direction of the AC EMF periodically changes. And magnitude of the DC remains constant, and the magnitude of the alternating EMF periodically changes. That is my answer. This is question number 9A part. You can pause the video. You can take your time with this marking scheme. Then he says the circuit, question number 9B part. The circuit includes 3 resistors and 2 open switches S1 and S2. Figure 9.1 shows the circuit. Okay. So this is the S1, this is S2. Both are open. This is 28 ohm, 20 ohm, 30 ohm, 12 volt battery. This is a wire ZY, YZ between 2 permanent magnets. Their north and south pole are facing each other. He says YZ is a straight horizontal section of connecting wires that lies between 2 magnets. S1 is now closed. So when you close S1, the current will flow from here and it will pass from here and go back. So now the resistor 20 ohm and 28 ohm are in use. He says calculate the current in the YZ. So the total resistance of this circuit will be 20 plus 28 ohm because they are in series. And the EMF is 12 volts, so I can calculate how much is the current. So the R equivalent in this case will be 20 plus 28, so that is 48 ohm. EMF of the battery is 12 volts, so the current coming from the battery will be EMF divided by the total resistance, that is 12 volt divided by 48 ohm, and that will be 0.25 ampere. So 0.25 ampere is the current which come out of the battery. Same is the current which will flow from the wire YZ. So the current in the wire YZ will be 0.25 ampere. 0.25 ampere is the right answer, sir. Marking scheme showing up. Okay. So there, question number 9 is B and its second part. It says explain why the YZ experiences a force. You see, YZ is a current carrying conductor which is placed in a magnetic field. So it will experience a force on it, and we call it the motor effect. And with the help of the left-hand rule, we can tell the direction of that force also. Another way of describing this is that the YZ is a current carrying conductor, and the direction of the current is from Z to Y. And the magnetic field around this YZ wire, due to the conventional current, is clockwise. So there are 2 permanent magnets there. Their north-south is facing, and their magnetic lines are going from north to south. They are going from left to right. So above this wire, the magnetic lines due to the electromagnet and the magnetic lines of these permanent magnets, they are in the same direction. And below this wire, the direction of the magnetic lines due to the electromagnet on the YZ, electric field around that current carrying wire, and the north and south of that permanent magnets, they will be in the opposite direction. So above the wire, the magnetic field will become very strong. Below the wire, the magnetic field will be weak. So what will happen? This wire will go downward. So due to the interaction of the magnetic fields, the wire will experience a force. We call it the motor effect. So I have written a big answer. I've tried to wrote down all the reasons. So you have to short this question. Okay, the answer, sorry. YZ wire is current carrying conductor placed perpendicular to magnetic field. Magnetic field around the wire YZ is clockwise. Magnetic field of permanent magnets is from left to right. Above the wire, both magnetic field lines are in the same direction. Below the wire, both the magnetic field lines are opposite. So wire will experience force in downward direction. Direction of force can also be found by using left-hand rule. So you don't have to explain here the left-hand rule, okay? So what they say YZ is a magnetic field, in magnetic field, and magnetic field between poles of the magnets, electric current in the YZ, and the magnetic field interacts with the field of the current, and that's why it experiences a force. So I hope my answer is right. But you have to make it little shorter. There were only 3 lines available. Okay, now we have the third part. This is question number 9. It's B and third part. Okay, he says, tick the box which describes the direction of the force on the YZ. That will be in the downward direction. So we will put a tick here. So I have ticked here. So hopefully you understand. Downward. Downward is the right answer, sir. Then we have explain how the direction of the force on the Y is determined. The force on the Y can be determined very easily by using the left-hand rule. And this is my left-hand rule. This is my left hand. And this is my thumb. This is my index finger. And this is my middle finger. So you stretch them in such a way that they are mutually perpendicular to each other. So what you do, what we will do, my index finger should be in the direction of the magnetic field, and my middle finger should be in the direction of the current. Then my thumb will be in the direction of the force which that wire will experience. So this is along the magnetic field of those permanent magnets. This middle finger is along the conventional current, and my thumb, which is pointing downward, that is in the direction that shows the direction of the force which that this conductor will experience. So let me show you my solution, the answer which I have written. So here we go. So stretch thumb, index finger, and middle finger mutually perpendicular to each other of your left hand. Align index finger along the magnetic field of permanent magnets, middle finger along conventional current in the wire YZ. Thumb of left hand will show the direction of force exerted on the current carrying wire. This is called the Fleming's left hand rule. So my answer is right. I know that, but the marking scheme is showing up. Current from Z to Y, page into page, and magnetic field left to right. Fleming's left hand rule, other appropriate rule mentioned or described. So this is the marking scheme. This is my written answer. So you can write always a better answer, but I hope this will be clear to you. Then the question is, he says C part, question number 9, C part, switch S2 in the circuit in the figure 9.1 is now also closed. Calculate the total resistance of the circuit. It's a 3 marks question. So they are basically saying that I have closed, this one was closed, now they have closed this one. So now this will be also included in the circuit. So this and this, they are parallel to each other. So first of all, I will find out their equivalent resistance. Then their equivalent resistance and this resistance, they will be in series with each other. So first of all, I will find out the 30 ohm and 20 ohm resistor, which are parallel to each other, their equivalent resistance. So 1 by R equals to 1 by R1 plus 1 by R2. So 1 by R equals to 1 by 30 plus 1 by 20. So 1 by R will be equals to 2 plus 3 and the whole thing divided by 60. And 1 by R will be equals to 5 by 60. So R will be equals to 60 by 5. So R will be equals to 12 ohm. Now the total resistance, this 12 ohm and the 28 ohm, they will be in series with each other. So the R equivalent of the whole circuit will be R plus R3, and that will be 12 plus 28, and that will be 40 ohm, 40 ohm, 40 ohm. So 40 ohm is the answer. By mistake, they have written here watts. This is not watt, this is ohm. Okay. Okay. So we are now going to the next question, and he says, the question explain what happens to the force on the YZ as the switch S2 is closed. You see, when you close the switch S2, the resistance of the circuit, which is now 40 ohm, and before it was 48 ohm. So now you see the resistance has become 40 ohm instead of 48 ohm, which was previously. The resistance of the circuit has decreased. The current from the battery will increase. So when the more current will pass through the YZ wire, it will experience a larger force in the downward direction. So my answer is that resistance of the circuit will decrease current flowing through the wire YZ will increase. Due to this, the force on the wire YZ will also increase. So our answer is that it will increase. So this is the answer. So that's the question is question number 9. It's C part and its third portion. Their question is the current in the 20 ohm resistor is I20 and the current in the 30 ohm resistor is I30. State a value for the ratio of I20 to the I30. So because they are parallel to each other, so the current flowing through them is inversely proportional to their resistors. So I20 by I30 will be equal to the resistors 30 by resistors 20. So I20 by I30 resistance, that's 30 ohm and 20 ohm, and it will be 3 by 2, and that will be 1.5 volt. A unique kind of question, and this part especially. So 1.5 is the right answer, 3.2, 1.5. This is the solution. I hope you understand this formula. Because they are parallel, so the current flowing in each of them is inversely proportional to the resistors. Because the current divides between these two. Okay, so that's it. So this paper is over, and my dear students, today in this video, we have attempted October-November 2022 2-1 paper. It's section B. In this video, we have only solved the section B. The section A of this paper I have already solved and it's already uploaded. And you can find that in the playlist whose name is paper 2 zone 1 section A. I will also paste the link of that video in this with this video. So thank you very much for taking out time and watching this video. I think it's a great blessing for me that I can make these videos which can touch the life of so many students around the globe. And thank you very much, all my students who are watching these videos. And keep studying and keep working hard. Thank you very much. Have a good day. God bless you all.